Okay, so now we're going to take what we did the day before and we're going to use it to solve story problems. And the work we show for story problems for the entire year is to draw a model. Now here's the thing. You can tell students to draw a model on this day, and you're going to tell them that, you're not grading their exit ticket unless there's a model for everyone and blah, blah, blah. You can make the model about compliance, but ultimately, at the end of the day, you want them to be using a model for the rest of their lives when they're trying to make sense of story problems or any kind of complicated set of relationships. And so rather than mandating it, obviously mandate it for kids who just are not sold. What you really want to do is you really want to be convincing.
It's 12 o'clock.
Oops. Sorry, excuse me. You really want to say, hey, you're going to be tempted not to draw a model, but if you do, it is going to help you so much. And let me show you what these two problems look so similar but aren't the same, right? Luckily, the cool thing is that this objective is built in such a way that, using the model is actually useful. We're not asking kids just to do it so we can force them to show work. And so really, explain that to them and let them see that as they're working, so that they really do draw models from now on as a tool, right? So we were talking about how an equation helps represent comparison problems and, pro for their prior knowledge, what comparison were we doing? We were talking about, 2 more, right, versus 2 times, right? And we were writing it as an equal sign, and we were saying, 6 is 2 times as much as 4. 2 times as much as 4 is 6, right? We were doing all that work the day before. Well, now we're going to try to write equations for these comparison problems, and they're actually going to be really, really hard. If you jump to this equation, you might get it wrong. And teachers, these are not in your PowerPoints. Feel free to add them. I just popped them up there really quickly just to not have to write quite as much because I'm writing with my finger. But equations are really helpful. Oh my God, by the way, this is 8. I was just testing you. 8 is 2 times as much as 4. Equations are really helpful, but they don't necessarily get us the right answer if we don't do some thinking about the story beforehand. Because look at these 2 stories. They both are about 8. They both have the word 4 times. It would be really tempting to just jump to the equation. 8 4 times is 32. I'd be like, okay, I'm all done, right? But if I really take some time and draw a model to show the relationships in these stories, I realize that they actually are 2 different equations with 2 different answers. It's pretty cool, actually. So let's read this one, and I'll show you how I draw the model. Otis has 8 gel pens. So I'm going to say an O, and here's Otis, and he has 8. And I'll put the 8 on top just in case I have to cut this, or I don't know what's going to happen. Now, Brave has 4 times as many as Otis. This is a sentence I really have to think about because obviously Otis is just the 8. When it says Brave has 4 many times as Otis, what I really need to think of is, does this mean Brave has more or Otis has more? And yesterday, we used an equal sign. So it might be useful to put an equal sign here. Brave equals 4 times Otis's pen, meaning Brave is the one who's multiplying what the other person has and having more, right? So when I draw Brave, Brave is the one that has 4 times as much as Otis. So I draw this 4 times. That's 8 4 times. And it's asking me how many gel pens does Brave have. So here's Brave. Whoops. Right? And it's 8 times 4. Brave really does have 32. Okay, great. So now let's do the next one. In this story, it says Brave has 8 gel pens. So now when I go to draw, Brave has 8. Brave has 4 times as many as Otis. I bet you were thinking it was going to say Otis has 4 times as many as Brave, and you were going to want to go and draw Otis and draw 8 4 times. But this is still the same sentence. Brave has 4 times as many as Otis. That means Brave has the most. Brave's is 4 times Otis's. So inside of Brave, you have to think of this. It's 4 times something. Do you get what I'm saying? Oops, this should say Otis. How many gel pens does Otis have? So I'm looking for Otis, and Otis has less, right? Brave has 8 times Otis. Brave is the most. That's a question mark. So now, I'm not wanting 8 times 4 equals 32. I'm wanting something else. Times 4 makes 8, right? Just like here it was Otis times 4 equals Brave, because Brave has 4 times as much as Otis. It's still Otis times 4 equals Brave. It's just this time they told us how many Brave has, and we need to work backwards to figure out Otis. We could also think of it as 8 divided by 4 is 2. Otis must have 2. I hope what you're seeing is these comparison problems can work backwards. Like instead of needing to multiply times 4, we might need to divide by 4 because we already know Brave has 4 times as much as Otis. We know what Brave has. We have to work backwards to figure out what Otis has. And the model really helps me see. Because here I'm thinking Brave has 4 times Otis. She should be bigger. And here it was the same. Brave has 4 times Otis. She should be bigger. Right? These are going to be a super challenge. And the model's going to really help. So now you just keep working. Matthew's mom is 4 times older than Matthew. Like, you have to draw it. Here's Matthew's mom. Right? She has 4 times Matthew. So she's going to be 4 times, and then here's Matthew. Right? I need that, right, picture to help me really see who is times what, right? Now, instead of doing a question mark, they want me to use an equation using y. Y is just like a mystery number. So if Matthew is y, his mom, right, is 4 times y. Y times 4 equals mom's age. We don't know what that is yet, right? If y equals 2, then Matthew's mom is 8, right? Because the mom is 4 times older than Matthew. By the way, that's crazy that Matthew would be 2 and Matthew's mom would be 8, but that's all good. There's another example. This one, they're asking us for what the multiplication is, so it's a little different. But still, we draw it, and we put our question mark. Here's where it gets interesting, because here's where I purposely divide problems to be solved side by side to really compare and contrast. And you really want to put the work on kids to draw the model themselves before you discuss it, so that they really grapple with why they drew the model the way they drew. It's not obvious how to draw the model. They have to read the words and decide, right? And then, based on that, they can solve the problem and tell you what equation that they wrote. And so this is where the real magic happens, and you can have some fun drawing those out. All right.